As we were waiting, guys, we don't really have any major new updates with Glider this week. Obviously, custom scope is out. So if you guys are interested in writing queries for Glider against custom contracts, please don't hesitate to use custom scope. It's a pretty awesome feature. We're also working on more additions and more upgrades to the chains. So right now, probably the most popular chain is ETH Recent, which highly recommend you use if you're looking for bugs. Very helpful as it just contains the most recent contracts that have been interacted with. And when I say most recent, it's past 37 days. And also, we have our upcoming glider contest. I'll probably announce that again towards the end of the call. If you guys haven't checked it out, go to Remedy's website and look at the contest rules. It's going to be a really fun contest. $50,000 is up for grabs. And all you have to do is write glider queries and find bugs. I think we'll give one more minute. Can anybody let me know if my video is glitching? Okay,
Yeah,
perfect.
it's
Yeah,
fine
sorry,
currently.
Zero. Not sure what's going on. Okay, guys, we're going to get started. Welcome to Remedy's Discord event. In this event, we have the great Riley. I can never pronounce your last name. Is it Holterhus?
Yeah, it's Holterhus.
Holterhus. Sorry.
Yes.
Yeah.
No
So we
worries.
have Riley here, who is a security researcher, and we are Remedy, of course. This is me, Jason. I am or thank you. I'm a glider security researcher at Remedy, and then also is Ellen, who is our I guess community manager would be a good way. Although you wear many hats at Remedy.
Yes, I think we can call it community manager.
Fair enough.
It will work.
So today, this talk is going to be about taking a bug from sort of conception of understanding I have this bug and converting it into a glider query. We approached Riley and asked him if he had thought of any interesting bugs that he wanted to have a glider query written for. And so we did that. He told us about this bug and we wrote a query. And so this talk is going to be broken down into two components. First, Riley's going to talk about the bug, and then in the second half, we will show off how that glider query looks and run it so everybody could see really how to take something from inception to glider query and execute it against the chain. If you guys have any questions throughout the talk, just post in chat. We'll pause when we have a good opportunity and ask either Riley or me any technical questions. Riley, let's get started. Tell me, tell me. Well, first, before we start, is there any good place that anybody could find you if they're interested, just to learn more about you?
Yep. Probably Twitter or X, I guess it's called, would be best. So my handle is just Riley Holterhus. And yeah, also if you have me on Discord here, then there's a link to my X as well.
Perfect. Awesome. So, so tell us about this bug that you had told us about. I never heard of it before, and obviously it makes sense once you told me about it. So let's break it down and uncover what you found.
For sure. So what this thing that I wanted to talk about is, it's sort of like a potential mistake that someone could make with the OpenZeppelin upgradable access control contracts. And I'll talk about it a bit more later, but this is actually a mistake that I've seen someone else um, actually make in an audit. So to explain first just how the access control upgradable contract works, the idea is that there are all of these bytes 32 roles, and each of these roles is typically just a hash of a string. And the whole point of all this is that you have all of these roles that you define in your contracts, and then you have certain members of each role. And with that, it gives you all of these helper functions to allow certain roles to call certain functions or to have certain privileges in certain ways in the contract. And this is a very common contract to use. And yeah, the only other thing I wanted to mention about this contract quickly is there's also a default admin role, which is a special role in the contract, which has a key of 0. And this typically is like the super admin of the contracts where you're allowed to do most privileged actions. So to go into an example of how someone might use this contract, I have like a code snippet that I want to talk through. So as I was mentioning, you can define your own bytes 32 role keys. And in this example, I came up with pauser role.
Mm-hmm.
And the way that this would work is that you would have a pauser role, grant it to a pauser address and initialize, and then here's that default admin role that I was mentioning earlier. And the whole point would be that the pauser role can call the pause function, and the default admin role would have a more privileged role. So maybe they could authorize upgrades. And yeah, that's basically all of the context you need for this bug. I'll actually even just give like 5 seconds if you want to look through this code snippet. It's very short, but there is a very big problem with this code. And yeah, I'm not sure if anyone saw it or not, but the idea is that this declaration here, it's not with the constant or the immutable keyword. It's just a public storage variable because those keywords are missing. And this is not supposed to be how these roles are defined. The problem and the reason why the upgradable contracts are the ones where this issue could arise is that if it's an upgradable contract, this contract will be deployed separately as an implementation. And then there will be another contract, which is called the proxy. And that will just be simply delegate calling into this implementation. And typically the way this works is that, or this is a very typical way for this to work. And the storage slots for the proxy are the only thing that actually matter. The storage slots in the implementation, they do exist, but they don't really matter for any purpose. And because of this issue that I was mentioning, where this is defined as a storage variable, this initialization logic will only run in the context of the implementation, which, as I was just saying, does not really matter. Where the storage does matter, which is in the proxy, this pauser role will just simply be uninitialized. And because it's uninitialized, it'll have a value of 0. And you can probably see where I'm going with this.
Mm-hmm.
Because the default admin role is a special role that also has a value of 0. In the proxy's context, whenever the pauser role is used, it's actually equivalent to using the default admin role. So because someone made this mistake of just simply forgetting a keyword, now whenever the pauser is granted the pauser role, they will accidentally have way more privilege than they are supposed to have. So for example, the pauser now has the ability to upgrade the contract because of this mistake. And yeah, obviously you can see why this would be an issue and why you would want to prevent this. So that's the context for what the issue is. And then a couple more points I wanted to mention. I thought this was a good candidate for Glider because or for talking through a glider query, because it actually did happen in the audit before. I wasn't the one who found the bug, but someone else did, and I thought immediately that this is a very subtle issue that someone might make. So yeah, if it's happened before, maybe it's been in some deployed code. And one other point is that it's pretty easy to miss this, because even if you make this mistake, the code still does work correctly. The pauser will still be able to call pause, and the default admin role will still be able to call upgrade. It's just that the pauser, it has the ability to call another function that they shouldn't be able to. But if you're not testing that, then you wouldn't catch it. And finally, I thought this would be a good candidate for a glider query search, because it's sort of like a structured mistake. I'm sure we'll talk about this in a sec, but probably is possible to just look through, firstly, all the contracts that use this access control upgradable, and then try to refine the search down from there. You could probably take a couple different approaches to look for this, but it seemed like it would be possible to look for with Glider. So yeah, that's the context on this.
Yeah, I agree. I think it's a really great bug for a glider query. What's interesting as you're breaking it down, I started realizing, like, typical, like, this bug probably, if you just were dealing with access control upgradable contracts and not dealing with any sort of like upgradable feature in that contract, obviously this is not a bug, and like you wouldn't have to worry about it. But it's interesting that who the person who found this bug probably had very intimate knowledge of both upgradable and access control, and was able to sort of merge those together in order to realize this bug that existed on the audit.
Yeah, exactly. I think firstly, it's hard to even see it, just because when this is correctly defined, the only difference is that there'd be a constant keyword here. So if you're
Mhm.
just glossing over the code, it's pretty easy to miss.
Yeah.
And then you're right, even if you do catch this, the way to think about all the consequences is pretty, uh, you have to have a lot of knowledge on how upgradable contracts work and what
Mhm.
would actually happen.
Yeah, yeah, for sure. I also think too that with this type of bug, so like I do a lot of work on thinking about libraries and how libraries could be misused. Not OpenZeppelin, but certainly I could, if I wanted to, look at OpenZeppelin. And this makes me realize that there's probably other, like, very interesting combinations of libraries that if you mix these two libraries together and you don't understand how both of them work, then there's a possibility for you to find other bugs as well. And so that would, if somebody was a researcher and wanted to expand on this bug, I think they could, and I think that'd be pretty interesting research.
Yeah, definitely.
Um, cool. Okay, so I think I understand what this bug is, and I'm sure the audience does too. Um, so once you told us about this bug, I did write a glider query for it. But first, I kind of want to, like, talk about what is glider, in case if anybody who's listening and not too familiar with it. Glider is a static analyzer, which is just a fancy word for saying a way for us to look for code patterns given a query written in Python. So I'll write a Python query, I'll run it in the Glider IDE, and we'll get back code results. This bug, as we both mentioned before, is a really great candidate for Glider. I've written a query for it, and I want to show that off to you. But before I show that query, I want to quickly talk about, like, the thinking process when you have a bug and you want to convert it to a glider query. Like, the biggest recommendation I have is to break down that bug into components and to think about what makes up that bug. In this case, it's like very clear characteristics. Like, the first one is, does the contract use the UUPS upgradable and the access control upgradable contracts? That's number one. The second thing you want to look for is whether or not grant role is called. I mean, obviously, I would hope that developers would always use the appropriate library that they have inherited in their contract, but sometimes they don't. So it's always very good idea to make sure that they're actually using the library In this case, we want to check for if they're actually using the grant role function, this is where the exploit occurs. And the final thing is that we want to check if the role that's passed into the grant role function is immutable or it's constant. If it's neither one of those, then we likely have an exploit. And so those three components I took and I wrote a glider query. Let me go ahead and share my screen with you guys. And we'll walk through the query real quick and you could see how it works. I assume everybody could see my screen. Okay, so let me increase the size a little bit. So I've talked about three different components for this query, and we'll just walk through each of these components. Before I run the query and discuss it, I just want to briefly mention that we did try to run this. We did run this query against mainnet and BNB, but we weren't able to actually find any vulnerabilities at the time, which means surely maybe there's some unverified contracts that still have this vulnerability, or maybe there is a contract yet to be deployed that has this vulnerability. So even though if you run a glider query and you don't find results, I would not be too worried about it, because there's obviously every single day new contracts being deployed. We always upgrade on glider, so you could keep rerunning your query until you actually do find a hit. But in this case, what I've done is we have a new feature in glider IDE called custom scope. And what custom scope does is it allows us to use custom contracts. And that's what I've done. I've created a custom contract that actually contains this vulnerability. So as I go through this example, you guys will see this result that keeps popping up. This is a custom contract I wrote or I modified to help us understand how this query works. So the glider query itself, which we're looking at, is broken up into three sections. The first section is we're going to look for contracts that have the UUPS upgradable contract inherited, and that's what this piece of code does. It's pretty standard, and we'll just go ahead and run the query, and it should only take a couple of seconds. And what it would return for us is it's going to return for us the UUPS upgradable. Actually, using a different chain. Sorry, guys. Okay. This is the custom scope chain. I'll rerun it. And what's going to return for us is the custom contract that I deployed earlier. Here it is. Perfect. Okay, so that contract right there inherits UUPS upgradable. That's step one. The next step is for me to also check if that contract inherits from the AccessControl upgradable contract. And what I've done is I've added a filter, which just filters out any results that I don't like. And in this case, it's going to filter out results that contain or that don't contain the AccessControl upgradable contract. And that's done here. So contract direct based contracts just pulls all the contracts that have been inherited, and we just check to see if one of them is AccessControl upgradable. So I'll go ahead and run this query again, and we should get back the same result as we do. Perfect. Okay. So that's step one. That's the first component is complete. The second component I have to figure out is how can we check to see if there are any functions that call grant role? And I could do that with these three lines of code. So here, I'm just going to get all the functions from the contract. I'm going to then call this really neat glider API function called with calling names. And what that does is it allows me to check to see if any functions call grant role. And then finally, I'll execute the query. So I'm going to go ahead and just run this. And what it should do now is it's going to return to me, glider ID is going to return to me functions that call grant role. And we can see that here. We can see two functions have been returned, and they both contain the grant role call. Perfect. Excellent. So this final component, which is now that we have this code, we need to figure out if this is actually a non-immutable, non-constant variable. Obviously, if we want to manually, we could go look at the code, but that's not where really Glider excels. Glider excels in our ability to programmatically check that. So this component is going to do a couple of things, and we'll just kind of walk through it by first stating that like this function will return true when we have determined if the state variable here or just variable here is non-immutable, non-constant. It will return false when it's mutable or it's constant. So let's go to this function. And again, I'm using the glider filter function to help me with this. The first thing we're going to do is given the function, because we have two functions here. We have this initialize function, and then we have this grant role function. We're going to go through all of the instructions. And instructions we could just think of as a line of code. Then we're going to call this glider API function called with one of callee names. And what that will do is that's going to check each line of code and see if the grant role has been called. And then we just execute this query. Now we have instructions, and these instructions all are the grant role instructions. So it should get back this. It should get back this instruction. It should get back this instruction, and it should get back this instruction. So with Glider, we're just breaking it down. We're granularizing the code to a point where we can analyze the individual lines that impacts this bug. So here we're just going to go through the instructions. Here, I'm going to get the value of the instruction. In this case, because we're calling another function, it's just going to return this entire call for us, which is very helpful. With a call, we could really granularize the data that we want to look for. We could sit down and ask like, what's the name of the call? What are the arguments, etc. So the grant role call represents the grant role call inside the Solidity code. We just do a simple check to make sure it's a call. And then if it is, we're going to grab the first argument, which is this really important argument that we've been talking about that we have to make sure is either a constant or immutable. Then I'm going to do a check that just makes sure that the variable that we're working with is an actual variable. It could be hard coded, for example. A developer could hard code this value, and we don't really care about that. We just want to make sure that, yes, it is in fact a variable. Next, we're going to get the object of the variable. And the object of the variable is going to represent, it could be a state variable, it could be an argument variable. In this case, for this bug, we only care about state variables. And so just a quick pause for a second. If anybody is sitting here saying, we're talking about var files, we're talking about state variables, we have a Glider API documentation that anybody could go to and look at. All this information is here. We also have Discord. If you guys just have questions about anything Glider related, I'm more than happy to answer. We also have others who are more than happy to answer. So if any of this seems a little daunting or confusing, please don't hesitate to ask us or follow up, or even in this Discord chat, I could explain anything here if you guys have any questions. So we're going to get the object of the variable, which is a state variable, and I'll assign it to the var object. And then here's where the magic really happens. So we've broken this code down. We have the call, the grant role calls, and we've identified the first argument passed into this call. And now we know if it's a state variable, we can now check to see if it's immutable or if it's constant. And that's what this line of code does. So we're going to first check to make sure it's a state variable. We're then going to make sure and check to see if it's not immutable. And then we're going to check to make sure it's not a constant. If it meets all these qualifications, we have effectively defined our query. We have found a potential vulnerability, and we're just going to return true. Otherwise, we'll ultimately just return false. And when we call this function, this declare role, a storage role, inside this filter, the glider query will effectively filter out all results for variables that are neither a constant nor immutable. So let me go ahead and just run this code since we've kind of walked through everything. And what we should get back is our result. Let me take a quick second. Perfect. Okay. So what Glider is telling us is that this function is vulnerable. And now if I want to, I could go and visit the actual contract. Since I've wrote it, I know where the vulnerability lies, but let's go ahead and go to the contract that I deployed. And I'm just going to look for this default admin role. And here it is. As we could see here, I've defined a public variable that's non-constant and non-immutable. And we could see if we keep scrolling down, eventually we'll reach a point where the code is actually used. And what I could do, just to make it a little bit faster, I'll just look for this function. And there we have it. Same function that was in Etherscan is found in Glider. And we can go from there. We could find out who the owner is. Obviously, I know I deployed it, but if this is on a live chain, we could figure out the owner of the contract, and then we could contact them and report the vulnerability.
Nice.
All right. So all that said, we have this Glider query. We couldn't find it on mainnet. We couldn't find it on BNB and other chains. So where do we take this from here? Obviously, we could keep rerunning this query on a daily or weekly basis. Or we could also think about, as we talked about before, this idea that we have an access control or an upgrade and an upgradable contract merged together that has created this vulnerability. We could take that idea and we could also apply it to other contracts. And this is obviously where like research novelty comes in, and the ability to just think about bugs on a and just think about bugs that have yet to be thought of, or find bugs that maybe are in like a few audits but just aren't really um, out there in the world, that's not well known. Glider excels at all of that. It also excels at finding very popular bugs as well. So it's not just limited to these very niche bugs, but certainly ways that you can think about are taking different type of contracts, merging them together. What's the consequences of that? What's the impact of that? Obviously, upgradable is a really huge component in this, and so is access control. So those are all things I think that if you're a researcher, you want to think about when you are working with contracts, and then also trying to make it work with Collider. So all that said, does anybody have any questions for me or Riley while we wait? If anybody doesn't, that's totally fine. You guys could also ask in our Remedy Discord after the call. I'm sure both of us would be very happy to answer any questions. Well, I think that is it for this talk. I don't think anybody has any questions unless Pangolin does. He's typing. Um, how are we viewing the results? So we're reviewing the results in the examples. We're using a feature called custom scope, which I haven't really showed off. I guess I could just quickly share that with you guys if you're interested in that, because that is like that's a really helpful component in this, not only for this demo but also writing the query, because obviously I want to make sure that I write the query correctly. So let me go ahead and just reshare my screen, and I'll show you guys what I did. Okay, so what I will do is I will go to the top here. We have this My Scopes button. I'm going to click on it. And what it's going to do is it's going to show us not only our case studies example, which every user gets to view, but we also have this ability, although it's sort of locked out for me, there's ability for you to create a new scope. And if you click on that, you should go to this page where you'll be able to add details about a custom scope that you want. And a custom scope is just a series of contracts that you can upload to Glider. And then every time you run a query, Glider will run against that custom scope. So you just fill out some information. And then here at the bottom, you could deploy up to 5 contract addresses. And what you do is you provide the alias name, and then you could choose the blockchain. We have many, many blockchains available to us. It's just not Sepolia, which is where I deployed the contract. So if you're actually wanting to run against a live contract, you could use one of the many ones we have here. Otherwise, highly recommend deploy to Sepolia. It's super fast, super quick, and you could test against all sorts of interesting bugs that you may not have an address for on a live production chain. Once that's all done, you could just click recompile, and there will be a compilation in progress. This takes only a couple seconds. And if we refresh the page, eventually it will mark it as complete. I promise it will be complete. Okay, there you go. Compiled successfully. So once it's compiled successfully, I can then go to my IDE, and then I could go to custom scope, and I could select the AccessControl upgradable, and then I can run the query, and we should get back the exact same result as I showed off earlier, which is the NFT contract I deployed. Yeah, there it goes. And this is the same one that's in custom scope. So hopefully that answers your question. If you guys want to know how to deploy to Sepolia, I'm working on a doc for that. But there's generally some resources online to help you get started with that. It's pretty. It's not too hard, I would say. Pangolin asks if we use this and found it valid, would we use this as proof if it was a BB on Remedy, for example, on the standard way with POC? Yeah, that's you can. Oh, you can. Yeah, you can. You would just mark. You could mark the contract and say, hey, this is the contract we found, and I want to. The query is able to successfully find a vulnerability in this contract, and then on the triagers end, the triager would then run the query and confirm it. That's a pretty good way of doing that. We also have like some functionality that we're working on to make it easier when you do like submit queries to point out those contracts that are true positives, and that helps both verify that you have the vulnerability, that you submitted it through the request, but also for us to also confirm that the query is valid and good to go and is finding vulnerabilities. So I think that is going to be it. Riley, do you have anything else you want to share? Any social media? Anything you're working on recently? Research?
Nothing too much new on my end. yeah, I'm just available on X, and I'm planning to try to participate in the upcoming CTF. So looking forward to seeing how that goes.
Excellent. Awesome. Ellen, is there anything I'm missing? I think that's it for us. Perfect. As always, again, just to recap, we have a glider contest coming up, and that will be running for about 2 months. It's $50,000, and you submit glider queries for found vulnerabilities on chain, and you get paid. It's a pretty great deal. If you guys have any questions about it, don't hesitate to reach out to us on Discord or ping us. We're happy to answer any questions about it. Go check out Remedy's website for more info on the contest. And that will be it for today. I'll see you guys next week. And I hope you have find many bugs. All right. Thanks, guys.
Thank you.
Thank you.